Hi everyone. Today I'm going to talk about pre, in, and post order traversal. These all three traversal are based on depth first search technique. In pre-order traversal, first we going to print the data at the root, and then we going to visit left subtree and then right subtree. And in order traversal, first we visit the left subtree and then print the data present at the root, and then we're going to visit the right subtree. And in the post order traversal, we're going to visit the left subtree and then right subtree, and then print the data present at the root. Let's do an exercise. In pre-order traversal, we start with the root of the tree. First, we print the data present inside the root and then visit the left subtree of the root, that is B, and again print the data present inside this root B, and then we start visiting the left subtree of B, that is D, and here D didn't contain any left and right subtree, so we go back to B and start visiting the right subtree of B, that is E. Again E didn't contain any left and right subtree, so we go back to B. As we already visited the right subtree of B, so we go back to A and start visiting the right subtree of A and print the data inside the node C. And then we go to the left subtree of C, that is F. Again we see that F didn't contain any left and right subtree, so we go back to C and start visiting the right subtree of C, and here we print G. And as you can see that G didn't contain any left and right subtree, so we go back to C as we already visited the right subtree of C, so we go back to A as we already visited the right subtree of the A. So here our algorithm and here is the pre-ordered traversal of this tree. In order traversal, first we visit the left subtree or and then we print the data inside the root and then visit the right subtree. So here, first we visit the left subtree of A, that is B, and here visit the left subtree of B, that is D. D didn't contain any left subtree, so we print the data inside D and then visit the right subtree of D. As D didn't contain the right subtree, we go back to B and then print the data inside the B and then visit the right subtree of B. And here E didn't contain any left subtree, so we print the data inside E and then visit the right subtree of E. And now E didn't contain the right subtree, so we go back to B. As B already visited its right subtree, so we go back to A. And now we print the data inside the A and then visit the right subtree of A, that is C. And here from C we visit to go to the left subtree of C, that is F. As F didn't contain any left subtree, so we print the data inside the F and then try to visit the right subtree of F. As F didn't contain the right subtree, so we go back to C and print the data inside C. and then we visit the right subtree of C, that is G, and again G didn't contain left subtree, so we print the data inside G, and we go and G didn't contain the right subtree, so we go back to C as we already visited the right subtree. So again we go back to A, and as for A also we visited the right subtree. So here our algorithm, and here is the in order traversal of this binary tree. In post order traversal, first we visit the left subtree, then right subtree, then we print the data inside the root. So here first we visit the left subtree of A, that is B, and B, from B we go to the left subtree of B, that is D, and as D didn't contain any left subtree and right subtree, so we print D, and we go back to B, and here we go to the right subtree of B, that is E, as E didn't contain any left and right subtree, so we print the E, and we go back to B as we already visited the right subtree of B, so we print the data inside the B, and again we go back to A and start visiting the right subtree of A, that is C, and and we go to the left subtree of C, that is F, as F didn't contain any left and right subtree, so we print the uh, print F, and again we go back to C, and from C we go to the right subtree of C, that is G, and print the data inside the G, as G didn't contain a left and right subtree. So we go back to C as we already visit the right subtree, so we print the data inside the C, and then we go back to A, and here uh, as we already visited the right subtree of A, so we print the data inside the A. And here our algorithm end, and here is the post order traversal of this binary tree. Here is a code for in order traversal. So as you can see, there is one base condition which indicate if the node is null, then return, and if it is not null, then we start visiting its left subtree, and then we go to and print the data inside this node, and then we start visiting the right subtree. When we do the in-order traversal of binary search tree, then we get the nodes in the non-decreasing order. Here is the code for pre-ordered traversal. The base condition is same. If node is null, then return. If not, then we going to print the data inside the node, and then we going to visit the left subtree and then right sub. Here, pre-order traversal is useful when we copy a tree or we need to find the prefix expression from an expression tree. Here is a code for post-order traversal. It's the same base condition. If the node is null, then return, and if it is not, then visit the left subtree and then right subtree and then print the data at the node. Post-order traversal is used at the time of deletion of tree or to find the postfix expression from an expression tree. Make sure to practice these concepts, code, compete, and win.